Welcome back. In this one, I want to talk about a little project that I came up with. But before I get to that, I want to talk about how I got here. So, went on a family trip, got into photography, taking pictures, and I found that I kind of liked it. So, I got a camera. You may notice that the quality of this video is a little different than the previous videos. And sat in the backyard and started taking pictures of birds. And the first few were not so great. I'll put some of those up if I still have them. But some were pretty interesting, and there's not a whole lot in the backyard. I'm basically sitting at a picnic table working on paperwork and taking pictures of the various backyard birds that come by. Things like robins, cardinals. I saw a hawk that made a nest in the woods that are behind the backyard, so that was pretty cool, and I've got pictures of him or her. But something I notice wildlife photographers do is they get really low to the ground, and if you want to get pictures of water birds that are over a lake or something, you want to get a low perspective so that you can get them in the center of the frame and get their full body and it's not distorted and stuff. So something they use is something called a skimmer pod. It's like a ground skimmer. You may also hear it as called a ground tripod or a skimmer tripod. Not really a tripod because it's really closer to a monopod. It's only touching the ground in one spot. But basically what it is just that. You mount your gimbal head to it, and now you can slide this thing around. I don't care if this part gets all beat up, but I can slide this around on the ground to get a nice stable platform for the gimbal head and take pictures of things really low to the ground. You lay on your stomach and you can take these pictures. I saw these online, and they're usually out of molded plastic or something. They're $100, and I looked at that and it looked to me like about $3 worth of materials. Obviously somebody went through the effort to design it, so that's what I just did. I went in AutoCAD, I designed, sliced, and then 3D printed one of my own based on just what I think it should look like. And this is what I came up with. So it's a 7.5-inch disc that has some supports, a 1-inch displacement from the ground, and a recess for a hex head bolt. I'm using a 3/8 16 1-inch bolt in here, and that gives you just a little bit over a 1/4 inch. It's about 0.3 of an inch to fit into your gimbal head. And most of those, like I said, are 3/8 16. If you're trying to attach this to your lens mount, you'll probably need something like 1/4 20. If you're interested, I'll put links to the files down below in Thingiverse so you could print these yourself. And if you're interested in having one that has maybe a 1/4 20 hole in it, a round socket for maybe a cap head bolt so you can use an Allen key to tighten it or something, just let me know in the comments. They're really simple to change those up, and I can make those if someone else is interested in it. But in this video, I wanted to talk about the process, what I did in the Cad software. I'll go through that and show you my model. I'll show you the settings I use for Cura, and lastly, I'll show you the 3D print and then little things about 3D printing. So I usually use a hair dryer because I wanted the tolerance to be pretty tight on this. So I made it just slightly bigger than the actual bolt size. So normally that wouldn't work. And what I did is I friction fit it with a heat gun. And what that does is it makes it so even though it was friction fit, once it's cooled off, it's not really going to go anywhere. And that's good. So now you can just screw in your gimbal head. You don't have to worry about it falling out. So that's what I wanted to do in this one. Don't worry about the two-tone colors. I had to change the filament in the middle of the print. But if you're interested, hang around, I'll show you those videos, and let's get on with the rest of the video.
So this is my workspace in Fusion 360, but before I get to that, let's move over to my Chrome tab. And this is basically what I was talking about. This is a purchasable version of the Skimmer Pod, and I honestly didn't know what that was, but it seemed like a cool idea, something with a bolt in it, until I realized this thing was $100 for a molded plastic. So I went here, I looked at it, and it looks kind of like what you'd expect. You put your gimbal head on top of this, and then it kind of gives you a platform for it to sit. It's 10 inches round, 1.5 inches tall. So those are kind of the dimensions I went with. Didn't want to just carbon copy it, but it's literally a frying pan with a bolt through the middle. I wanted to see, though, what other ones looked like, and that was the only one I could find. This is the manufacturer for it, same price, and it's also available on Amazon. People seem to like it. I didn't buy one of these because I have a 3D printer, so I decided just to print it on my own. So let's switch over to Fusion 360, and I'll show you what I came up with. And I have two versions here. First, I'll show you the one that I made first. So I kind of went with the same dimensions-ish. This is 10 inches across And it's got a 1/4 inch recess here for the head of a hex bolt. You can see there, so it'll sit inside there, and then the bolt head will sit along this outer portion outside of the bolt hole, and that's what will keep it from falling through. Other than that, it's pretty straightforward. It's got an inch worth of this. So if you have, I used a 3/8/16 bolt, so that's what goes into your gimbal heads usually. And that'll leave you a little bit more than a 1/4 inch coming out of the top here to thread in. So about 5 turns. Is 0.3 inches is what I measured. And that's sufficient to get a nice stable connection to the gimbal head. And otherwise, the construction's pretty simple. I drew a circle, I extruded it up into a cylinder, cut out a bowl basically, and then chamfered the edges and then chamfered the inside, and then left this section in the middle, punched a hole through it, then did the one more sketch, and then did a small cutout for the bolt head. I did make this pretty tight, so the tolerances here are pretty tight, and I'll show you why in a minute. I wanted it to be friction fit, but we'll get to that. Other than that, though, it's pretty straightforward. So there was one issue with this design, is it's 10 inches across. So that's 260 millimeters. A lot of people don't have 3D printers that are that large. I bought one specifically that's big because I wanted to print these larger items. So what I actually did is I went through again and remade it. And this one is 7.5 inches across. Otherwise, the dimensions are the same. It has the same hex head recess in the bottom with the 1/4 inch recess. And then the 3/8 diameter hole in the middle for the 3/8/16 bolt to go through. But you can see here the across dimension is 7.5. So that's about 200 millimeters. And that works because a lot of those mid-sized 3D printers are about 220 millimeters, and this will fit on there. So you'll have an option if you don't have a 3D printer that can print the larger one. This one is about 200 millimeters across, and that should work. Next, I want to go into Cura and show you what settings I used. Okay, now in Cura, Cura is a piece of software that converts 3D models, so like STL files, into G code, basically actual like code that the machine language of the 3D printer uses. And you can see here's the file that I was just showing you. This is my workspace setup for my Mega X. So basically, I just used the kind of default settings, a 0.2 layer height, the normal 3 line count wall thickness. I didn't really change anything in top and bottom. These are kind of my generic settings that I use for everything. I did use 50% infill, and I like the gyroid because it gives you structural stability in all directions. But I do recommend using at least 50% infill for this so that you have good structural support. Those are my temperatures that I used for the PLA that I'm using. 190 worked for it. Supports. I did add supports, and I wanted supports because there's this little bit of an overhang here. See where it's red? Support overhang angle is 55 degrees, so that's why it's red there. It basically just did a couple little squiggly lines underneath and built up, so it wasn't much filament. What I really wanted the support for was inside of here to make sure that this doesn't get messed up and cause the bolt hole in the middle. So I do recommend just using supports. If you cannot do a hard 90-degree shelf like this, you got to really fine-tune your printer and use a small layer height in order for that to work out. And that's it for the computer portion. I'll switch over to the final printed part and show you that next. So here we are looking at the heating station that I have, and PLA usually melts at about 200 degrees Celsius. So I'm going to put it up to 210 because I don't want to get it too hot, but I want to melt it rather quickly so I can push the bolt in there. And really I'm just using the heat gun, pointing it at the bolt so the bolt heats up. I have the airflow set to a pretty low setting and heating both ends on it. And once it's hot enough, I'm just laying it flat and kind of shoving it into the hole once it's lined up properly. Here I'm putting it on this little platform so I can mash it in all the way while it's still hot. Just makes it fit a little better, and that's it. That's friction fit. I went and ran water over it to cool it off, and that should make everything kind of solid. And that's the Skimmer Pod. Let me know if you have any questions down in the comments below. I'll see you next time.